viewers, welcome. So in this tutorial we are going to show how to find out a linear regression through using TensorFlow, and thus we will find out one of the implementation or example of TensorFlow gradient. So let's dive in. Let's see. Import numpy as np, import matplotlib dot pyplot as plot, import TensorFlow as tf. Now we are going to make a class for the model. So define model. Now make a class or named as model, or you can give any name. Now I want to make the init function, pass out there self, and now I want to make two variable of w equal to tf dot variable 10.0. let's initialize self dot b equal to tf dot variable minus 5.0. So you can think linear regression as an equation of straight line. So for a straight line I will need the slope and a bias, and here w is the slope and b is the bias. Okay, so y equal to wx plus b. So this is the equation which we are going to create. Now we don't know the value of w and b, and for that reason I have to train the model. Okay, and initially I have made some arbitrary value and made w a variable instead of constant, so that I can change the w and b. Now make a function call so that I can make the class callable and pass out their self and inputs. Now I want to return self dot w star inputs plus b, self dot b, sorry. Now come out of the model, just define compute loss. So this will be another function, and here I will give the original y true value and the y predicted value. So this predicted value will be predicted by this model, and y true we will get this from the label value. Okay, now all I have to do, just return tf dot reduce mean and tf dot square y true minus y bit. So from each of the value of y true I will subtract the predicted value, and then I will square the value, and after that I will sum all of them and make a mean. So okay, fine. Now model, make an object of model. So model, fine. Now let's create some data for the regression. So through w equal to I am giving 3.0. This will be the true w, and true b, this will be 2.0. so just arbitrary. Now I'll be making some data with these values. Now examples, how many examples I do want. Let's say 1000 data. So let's make inputs equal to tf dot random dot normal, give out their shape equal to 100. Num of examples. Now okay, just plot this one, try to plot this data, plot, give out the inputs. So let's see what I have created. So you can see, so this is my data. Okay, now I want to, so this is my input data out there. Now if I, okay, this is the input data. Now I want to make the output, so random output. For that reason, outputs equal be, I will be using this true slope value and this bias value. For that reason, true w multiplied with inputs plus give true bias, true b. Okay, now I want to, okay, so now just plot this one. So plot dot plot and pass out their outputs. Let's see what I got. So you can see I got this value. Okay, so inputs. Okay, so this is the value what I got. Now all I want to do is I want to add some noise with this output. For that reason, so write out there outputs equal to output plus read out there tf dot random dot normal, and make pass out there number of examples. Okay, now I got an error. Okay, give out their shape. Yeah, that should be fine. Now let's plot outputs. Let's see the data. So this is my data. Okay, now if I let's okay, I should have plotted this value. Okay, now I want to here again, let's make this data output here. So output equal to slope, input and bias. Now let's plot with respect to inputs, and you can see I got a straight line. So it is already linearized, but I want some random data. Okay, so that I can train and find a line like this one. Okay, for that reason I want to use some noise with the data. Now so this is the noise which I added. Now I want to plot with respect to inputs. So let's see what I got. So you can see this is my data now. So it's not a straight line, so it will be hard for my model to train. And instead of plot, let's keep out there scatter, so that you can get a better intuition. And so this is the data out there. So now with this data I want to find a straight line. Okay, this is what will be the straight line which I am in search of, and this is the data which I will be feeding to my model, and I want to find a straight line like this one. So how can I do so? For that reason I have to train my model. So this is my model. I have a created an object of my model. Okay, and give a loss function out there. So you can see this is my loss function out there. Sorry for the interruption. And so this is the loss function out there. With this loss function I will train my model. So let's do so. What can I give some hyperparameter, learning rate equal to 0.1, and give out there for epoch in range of 30 with tf.GradientTape. So now I will be using the GradientTape function. So pass out there is tape. Now give the loss function out there. So loss equal to compute loss, and pass out their outputs. So these are the what should I say, this is the y true value. So here I pass the y true value. Now I want to pass the y predicted value. For that reason I have to call the model and pass out their inputs. Now what I will get, so this is the loss function. Now I want to get dw and db. For that reason just tape dot compute, sorry, gradient. Now give out their loss function, and I want to find w and b. So for that reason I have to give out their model dot w and give out their model dot b. Okay, so this is the two parameter I want to train with respect to loss. Okay, and now what I will get. Okay, so let's see what I will get. Oh, it will be a loop, sorry. So let's see one of the w. So this is one of the value of w and dw, sorry, that is the gradient, and this is one of the value of db. Okay, so this is what. Now come here and write out there model dot w dot assign sub. I want to learning rate, use the learning rate and multiply with dw. Okay, so this is model.w. From the model, so here I have given a value of w, that is 10. Okay, now I want to subtract this w, okay, with its slope. And if you don't know how linear regression works, or the loss function, or the gradient descent works, I will suggest another video of mine to look at. So I will be giving the link of that video. So model dot b dot assign subtract, pass out their learning rate, and multiply with db. Okay, so this is the two parameters I want to change. Okay, so let's print out so that we can see the loss in each epoch. So epoch, give out their %d and w2. Okay, instead of w2, now current w. So current w frame in each epoch. So pass out there %.2f. Okay, and after that b frame in each epoch I want to see. So %.2f. now give out there percent and write out there, give out there epoch +1 and pass out there model dot w, so that I can, and model dot b. So this is the two parameters I want to pass, and finally I want to give a. Okay, so this is all. Now just run this code. Okay, I got an error, learning rate is not defined. So learning rate, okay, that should be fine. So you can see after each epoch I am bringing my w. Initially I had value of w is 10, and you can see after each epoch, after each training, the value is tending towards the 3, and you can see finally I got 3.05, and here I have given arbitrary value of b as -5, but my target value is 2. So you can see after each training steps I am getting bias value to tending towards 2. So just delete these two cell. Okay, so I have trained my model. Okay, and now I am fine to predict through my model. So let's do so. So now print output equal to model and pass out there just the inputs. Pass out their inputs. Okay, and now I want to plot. So plot. So give out their input and give out their output. Sorry, print outputs. Okay, now plot dot scatter, give out their inputs and give out their outputs. So let's see. Okay, so this is my straight line out there, so I should give a color out there. So just give a color. So give a color of C, and here give a color of G. Okay, that should be R. Okay, so you can see this is my straight line which I got for through training my model, and these are the points, these are the data points, okay, for which I got this regression line. So this is how you can perform linear regression by using TensorFlow, and this is one of the use of gradient descent. And as always, thanks for watching.